Welcome everyone. This is video number 8 based on my book Learn Harmony v3 for PIC32MZ. In this video, number 8, I will show you how to add and test a web server using the Harmony TCP/IP library components we developed in the earlier video number 6. As a reminder, all of the custom source code used in these videos is available from GitHub. If you have not already downloaded the file learn hv3_figures.txt, do it now. So before we continue, I want to give you some information about HTTP and HTTPS web servers. The HTTP URLs begin with http:// and use port 80 by default. The HTTPS URLs begin with https:// and use port 443 by default. Now, HTTP is not encrypted, but HTTPS is encrypted, encrypts all message contents, and uses the TLS protocol, which requires a third-party package to work with the Harmony TCP library. This is needed because Harmony does not have a TLS library, so they include a set of Wolf SSL libraries with the net download. So what we're going to do in this video is clone the MZEF layers project, which has all the basic TCP/IP libraries. We're going to add the HTTP net software component, NVM, non-volatile memory driver, and the file system software components to our project and configure those so that they'll work in this environment. And we'll add a state machine called HTTP_net_SM that listens on port 80 at the static IP address for client connections. When a client connection is made, then the project will serve the requested web page, which is using the Microchip demo set of web pages. By the way, the Microchip demo project, web_net_server_nvm_mpfs, is included in the net app software download from GitHub. This is the standard TCP/IP library demo that is used to show how to create the web pages. So what you'll see in this video is kind of a subset of that, or directed more towards understanding how it works and not how everything in their demo project works. Okay, so let's clone the layers project so we can use all the software components that are in that. To do that, we're going to duplicate this, change the name here to HTTP net. Okay. Then go over here to MPLab X and open that project. And click on the old name there under that project. Okay. We have to do a rename. Oops. Right click on this. Rename. Layers. Make this the same as the name on the file. Okay, there you are. It's been cloned. Now let's start up the configurator because we're going to need to add some more components for the HTTP net server. We'll come back to this when it's done. Okay, so project's now loaded where it was at the end of the layers project. Now we have to add some components and configure them. So let's get rid of these. And we're going to have to add is a memory driver. And system services file system. So we have a file system for the web pages. Library, we need the layer 7 HTTP net server. And finally, peripherals will need some non-volatile memory. Okay, so there we have the 4 additional components we're going to need to rearrange these and make the connections. So memory to memory, and drive media to drive media. Okay, now we just have to configure these new ones. And to do that, let's get a right click up here in the title, float that group, and move it over here, expand it past what we had there. And let's go with NVM, nothing to do there. Memory, nothing to do there. Instance 0, we have to switch this memory device type to NVM. File system, we need 25 more simultaneous file access. So you have multiple users, obviously. We're going to allow both file system types. We're only going to use the one, but we're going to use the Microchip file system for the web pages because that's what the demo uses, but we'll configure it so that you could use the FAT file system. The HTTP net server do not include the custom template. That's the source code, this custom code to handle all the options that are included in the Microchip demo web pages. We're going to have our own custom code that's going to look at only a small subset of what's in the Microchip demo pages. Advanced settings, I believe everything is okay. So we're done with that one. And now we have to make some changes in the presentation layer because for getting ready for HTTPS, the encrypted web server, we have to support encryption, and we're going to use Wolf SSL to do that. And we're going to support encryption for all of these. Auto activation of that configurator, no, do not use those. There and there. So we're going to support all the encryption possible. Just set it up for all of that. So if you want to use it, it's there. If you don't want to use it, it's okay, or delete it later. Okay, so now put this back, right click it, dock the group, close it, and let MHC generate source code for all these new elements plus the configurations. And this may take a while, so we'll come back to it when it's done. Okay, this is the merge file for TCP manager where we had to add the include file. We want to keep that. We don't want to take it back out. Okay, now this is the initialization.c file. So we've added all these components in, and we can put them in one at a time or do them all at once. So let's do one at a time just for the fun of it. This is the stuff that has to go in there for memory. Next. WebServer module. It's added, yes. That's an edit type thing. Notice we just missed one for whatever reason. This thing sometimes misses them, but yes, we want the 4 net presence for the possibility of 8. This way we have all 8 of them. Collapse that one. Media. Yep. We want to leave that one. We want to include this one. So those are editorial type of things. Goes in. Come on. Don't want that one. Don't want that one. So we should be left with 3. We see 5. Now this one's just editorial, so we'll accept that one. See what we missed. Oh, we missed that one. Okay, so we have 3. Just to check again. Yep, that one, that one. Okay, so everything on this side is now correct. Let's close that. All right, so we've regenerated all the source code. MHC has regenerated the source code that it needs. So, and we've configured everything. Okay, at this point, if you were to do a complete clean and build on the project in the current versions of the downloads, you'd get an error, a load error due to the datagram encryption choice. There's a way around it. You go to configuration.h and uncomment or comment out the define no old TLS, and then the compile and load would work just fine. There may be other side effects, but at this point we're just trying to show how to get this thing to work at all. If you were to do this and didn't get a load error, then they fixed it, in which case just keep going on. So what we're going to do now is add the custom source code. So we go up here to header files, new H32 header. We're going to call that HTTPnet. Source file, new. Call that HTTPnet. Okay, we'll select all, clear these out. Go to our figure learn hv3 underscore figures.txt and Copy that here. C. This is all the source code to control some of the basic functions of the Microchip demo web pages. Okay, and we have to go to app.h, add httpnet.h, just added, and then go to app.c and add httpnet initialize, httpnet underscore sm. Okay, so we've got all of the source code, the custom code all in there. We've redone the MHC code, so now let's do a, should all compile. Let's do just a complete clean and build and download. Green down arrow. Start that up. And we'll come back to that when it's done. Okay, programming is complete. Let's go back a little bit here and verify that we got the build successful, and then the download programming verify complete. So all of that is working just fine. So remember, at this point I had that one fix to make it load properly. We'll bring up the browser and type in HTTP. This is the address for our static address on our board, and there it is. The main page shows the buttons, LED going off and on, random number generator. So this shows that it's all working. Okay, so now what we need to do to change the from HTTP to HTTPS, we've already got all of the software components, everything in there. We could go back to the project graph and change the port number here on HTTPnet, the listening port there, to 443, then go through, regenerate the thing, recompile everything. But there's another easier way that, just for the sake of demonstration, is open up the configuration file here and go down and find the listening port, which is somewhere down here. There it is. Net listening port 80. Let's comment that. Now put in 443. We still do have to recompile, but we know it'll recompile, so let's just hit the green down arrow and let it compile and download all in one fell swoop, and we'll come back to that when it's done. Okay, build was successful. Now we're downloading. All right, we've downloaded the HTTPS web server to the device. Now let's try to test it. This gets a little trickier because this requires certificates, authorizations, CAs, and each browser handles it slightly differently. So I've got 3 browsers on this machine, and only one of them will allow me to look at these web pages. It says it's not secure, but it remembers when I figured out how to make this work. I believe what I had to do was click on this, and it allowed me to serve the web pages. But anyway, there they are, the same web pages. Okay, at this point, we have a project that includes both the USB library, the TCP library, and has an HTTPS web server that serves the Microchip demo pages. In the next video, I will show you how to convert a Superloop project to use the free RTOS library. We'll make this a real-time operating system controlled project instead of the Superloop. But we'll start with the projects that we've already created and make that simple conversion. Remember to hit the subscribe button. Thank you for watching, and I'll see you in video number 9.